Hello, my name is Rob Reynolds. Welcome to Calculus section 7.9. Today we're going to get the basic idea of differential equations, sometimes known as separable variables. We're going to separate the variables here. You can see I got a dy and an x on the same side, and I want to get all the y's on the same side and all the x's on the same side. So I'll do this in a couple steps, although I think you should be able to do it in one step. And I'm going to divide through by this negative 3y. So again, we could have done that all in one step, but I'm just showing you how I'm getting all the y's on the same side and all the x's. The next thing I'm going to do is use the constant rule and pop out that negative 1/3. I still need to integrate both sides to get rid of my derivative of y. And so I've got dy over here, and I'm going to integrate this side, which is dx. So I will integrate. Of course, this is the natural log of y, and over here I get x, and somewhere I have a constant floating around. That doesn't matter if I add the constant to the left or to the right. Next, I'll multiply through by negative 3, and again, that's going to change this constant. And the book keeps track of constant 1 and constant 2, but in this case, it doesn't really matter, so I'll just call it, well, that's a different constant. You can say constant. Sometimes they say sub 2 down there, but I'm just going to say no, it's just some other constant. Doesn't really matter. Later, I'll worry about constant 1 and constant 2, and I'll tell you the difference. To solve for log, we're going to do the fishhook, or the definition of logs. E to the negative 3x plus c is equal to y. And my final solution then would be, well, do you know that x squared times x cubed, you rewrite the base and add the exponents? So if the exponents are being added down here, e to the negative 3x times e to the c could be my y. We usually don't move from step A to step B. Normally, we're given step B, where the base is e, and we rewrite the base and add the exponent to move back to A. But in calculus, sometimes it's helpful to break things apart because this is just another constant, because e is a number, 2.71828. So e to the negative 3x is really my function of y. And if they give me a point, I can plug in the 10 for the y and the 5 for the x and solve for c. It's not very nice. We'll just leave it maybe e to the negative 15. Well, actually, I can bring that up. This is really 10e to the 15th. So the final answer would be the function given at this point would be y is equal to 10e to the 15 times e to the negative 3x, but I can multiply that back together, rewrite the base, and so I kind of pull it apart and put it back together. So there's your first look. Uh, if you'd like to see the video of that, I stole this from Krista King. She's also teaching calculus online. She has great videos. And by the way, if you have an old textbook, this is from section 8.1, and the newer textbooks here at DMAC is from 7.9. So when they say find the general solution, they give you the derivative. Of course, it's as easy as integrating. So just a quick review on integrations of cotangent. Again, I'll give you oh, that's not cotangent. It really is cosine. I'll give you a cheat sheet, but you should have a couple things memorized. And the integral of cosine is one thing that you should know, that if you take the derivative of sine, you'll get cosine. And the integral, well, this is a u sub. You're going to have to divide through by the 3. Watch a previous video on how to do that. So 6 divided by this 3. And it's no longer sine, it's cosine, because the derivative of cosine, or the integral of sine, is negative cosine. So that's why this goes negative cosine of 3t plus c. Sorry, I kind of botched that a little bit. Let's try part B, see if I can do a little bit better. Let's just integrate. Now, by the way, this is the second derivative, so I'm going to integrate twice. So the first derivative is 5 halves t to the 4th minus 18 t to the 8th. Again, remember, all I'm doing is I'm taking the 7. Integration means increase. So I increase it to 8, and then take 144 and divide by the 8. So let's do it again. This 1 goes to a 2. Of course, I have a plus c out there that I don't have a whole lot of room for. And then I divide by that 2. This 2. So 12 divided by 2 is a 6. Remember how to integrate? But that's not what they're asking for. They're asking for the original function, so I need to integrate again with the c out there. So this is where I'm going to end up with that c sub 1 and c sub 2. So let's do it again. This increases to a 5. And if you take 5 halves and divide by 5, you just get 1 half. T to the 5th minus 2t to the 9th plus 2t cubed plus c sub 1t, because I integrated this, and then you end up with a. And of course, here are worked out solutions, which you can check out on Blackboard. I hope you've printed off the PDF file and you can do this problem hopefully now. This is the derivative. So go ahead and pause the video and see if you can't find the original function by integrating 10e to the negative t over 2. And of course, you would do a u sub. You would let u equal that negative 1 half t. And then, of course, you have a du, which is the negative 1 half dt. And then there's really a dt here because this is really what dy over dt. And then, so to solve for that dt, you would multiply both sides by what? Negative 2. Negative 2 times this 10 that gets popped out becomes a negative 20 plus c. And then you could evaluate that at 0 and end up with negative 20, 0 divided by 2 plus c, and then solve for y sub 0. It says is 4. E to the 0 is just 0, and of course then c is 24. And then you could write down the final answer. Y sub t is equal to negative 20 e to the negative plus 24. So let me show you again, here's worked out solutions that the author worked out for this. Let me show you a problem that we have to use integration by parts, which is what we learned back on the previous section 7.2. So here you have a product, and remember, we don't know how to take the integral of AB. We've got the product rule for derivatives, but there is no product rule for integration. We have a technique called integration by parts. It's this UV minus integral V du. So go watch that previous video about how to integrate by parts, where you're going to not just only do a U sub, you're also going to do a dv. So we're going to let u be the more difficult. Well, no, we always let dv be the more difficult, but I don't know how to integrate lnt. Well, I do, but it's not easy. So sometimes I deviate from the book a little bit, but if we could integrate this, because the book says let dv be the more difficult. My rule is I let dv be something I can integrate. So I can integrate 4t squared to be 8t, and then I can take the derivative of this over here, which is 1 over t dt. And then I can go to my rule, uv minus integral v du, and of course, plus I have to integrate that 9. So we don't want to forget about him right there. So this guy becomes 4t squared ln minus the integral of 4t squared times 1 over t dt plus 9t. Bringing down this guy. So now I've got to, well, can I simplify this? This is the integral of just 4t dt. So I'll leave this 4t squared ln t minus 2t squared plus 9t plus c. So nice little review of integration by parts. Again, here's how the author chose to. Here's a nice little example. Example 4, I'll do part A, but then for the sake of the video length, I'm not going to go much further beyond. You can basically, they give you the acceleration, the second derivative, and we are going to integrate that. It says that it's 9.8 dt to find the velocity. Remember, the first derivative is equal to the velocity of the function, which is just the integral of the acceleration. So negative 9.8 t plus some constant, we can call that c sub 1. So at v sub 0, the initial velocity, it'd just be negative 9.8 times 0, c sub 1. So of course, v sub 0, the initial velocity, would be equal to c sub 1. So if we wanted to find the position function, we could just integrate this negative 9.8t plus v sub o, which is my constant. I'm going to call it v sub o because that's my initial velocity, dt. And if I continue integrating this, I'll get the position function. So negative 4.9t squared plus v sub o t plus some other constant. Remember, at initial height 0, this goes to 0, 0, c sub 2. So this s sub o, the initial height, is my second constant. So my final position function would be negative 4.9t squared. Perhaps you've seen this formula before, but that's s at o, the initial. So then I'll leave you with part B and part C, where you're literally just finding v sub o over 9.8 and just plugging that in for t. I'll leave that for part B. I skipped, and then you can look at part C for the sake of video. There is a cheat sheet. There's lots of integration techniques. Here's that. Remember, I told you I knew that what the integral of the natural log of u is. Here it is. This is one of the ones that I would try to get memorized, but oh my gosh, there's a lot of common integrals that I just use cheat sheets for, and you're welcome to do so as well. Example number 5, again, separation of variables. We're going to throw all the x's on the same side, so I'll multiply both sides by dx, and then I'll divide by y squared. So dy, I'm just going to write as the derivative of y, or y prime, over y squared is equal to e to the x dx. Then I'm going to integrate this, the integral of 1 over y squared, and then I've got dy, or you could write it as y prime, is e to the negative x dx. So I'll integrate this. Negative 1 over y is equal to negative e to the negative x plus c. And then solving for y. Well, to solve for y, I'll just take the reciprocal of both. So I'm going to flip, let's flip and negate. So it becomes y is equal to 1 over e to the negative x, and if I'm negating, that plus c goes to a minus c. Then I'll evaluate at 0, because it says y sub 0, by doing 1 over e to the 0 minus c, and it says y sub 0 is 1/2, so 1/2 is equal to 1 over 1 minus c. Let's flip again, so 2 is equal to 1 minus c. You can do that. Just what I'm doing is I'm literally just taking the reciprocal of both sides, or raising both sides to the negative 1 power. And then I'm solving for c. So c turns out to be negative 1. So y is equal to 1 over e to the negative c plus 1. And here's the author's solution for that. Some more examples is just problem number 31 from your textbook. So on this one, dy, I'm going to, let's just multiply through by y. I'm just going to integrate as well. So the integral of y dy is equal to the integral of 3t squared dt. So let's increase this to a 2, divide by it, is equal to t cubed plus c. Solving, y squared is equal to 2y cubed plus c. and square root. Y is equal to plus or minus the square root of 2t cubed plus c. And let's go again. I'm going to integrate both sides. 1 over y dy, because see, I divided both sides by y. So this y, this y, if I divide this side by y, I divide this side by y, which becomes that y. And then I'm going to multiply both sides by dx and bring this guy over here. So I got all the y's on one side, got all the x's. I multiplied both sides by dx and divided both sides by dy. The integral here is the ln of y, 1/3 x cubed plus x plus c, just practicing integration techniques. And then I do my e to the definition of logs, b to the y equals x. So again, you could say this is really e to the negative 1/3 x plus x times e to the c, and just bring this out. I don't know if the author will do that. Maybe he'll just leave it. So, you know, I don't know what my math lab will look for. Maybe either a step A or it might look for step B. Let's see what this author did. He just left it. But just realize if it's a multiple choice test, it could come in a different form. So for this one, I got a y and a t on the same side. So again, you could think about this as dy dt is equal to this. If you wanted to rewrite it, I'll slow down a little bit and show you what I'm doing here. So if I multiply both sides by dt and integrate this side, I'll get the integral of sine t dt. Then I'm going to divide both sides by this pink. So, geez, I'll write it. Dy divided by e. This becomes the integral of e to the negative y over 2, and I have that dy is equal to the integral of sine t dt. So again, just practicing separation of variables, which is not always possible. I should probably show you a couple of those examples. Here I'd have to do a u sub. Why don't you just pause the video and see if you can do that yourself before I come up with it. And then I see a negative 1/2 for du, so I'll have to multiply both sides by negative 2. Squared is equal to negative cosine t plus c. So e to the negative y over 2 is equal to, let's multiply both sides through by negative 1/2. Again, that's a different constant, but if you just want to keep it c, I'm fine with that. Let's take the natural log of both sides. So do the natural log, both sides. I'll dump this out front. So it's negative y over 2 times the natural log of e, which you know as just negative y over 2, is equal to the natural log of all of this. Using some log properties here, this is a good review of the whole year, actually, and then multiplying through by negative 2. The last example, let's see if the author got the same thing there. Yeah, that looks good. So the last example, separation of variables. I'm gonna divide both sides by w to the 1/2. And then when I integrate, since this is in the denominator, I'm going to bring that up to the numerator and then keep the dw. And then all of this I'm going to multiply by the reciprocal. So I'm going to put the dx on top. So I'm going to be multiplying by dx over x squared. So I'm going to integrate the 3x plus 1 over x squared dx. Then if you remember, one of the techniques is to break this up. There are other techniques, tables and charts and factoring and integration by parts, but I think this is the easiest for this one. So this is just integrating 3 over x plus 1 over x squared, which is 3 ln x minus 1 over x plus c. Over here, we just get 2w to the 1/2. I'll just bring this down here. Let's divide through by 2 and take and square both sides. So we just get W is equal to divide everything through by 2 minus 1/2 x. Well, the c gets divided by 2. It's just a different constant. And then remember, square both sides. Okay, that will end this video. I forgot my absolute value sign. If you have any questions,